this question is about oxides. Sodium oxide forms a solution with a higher pH than magnesium oxide when equal amounts in moles of each oxide are added separately to equal volumes of water. So sodium oxide, magnesium oxide. So sodium oxide forms a solution with a higher pH, so more alkaline than magnesium oxide when added to water. State why both oxides form alkaline solutions and suggest why sodium oxide forms a solution with a higher pH, more alkaline than magnesium oxide. So the point is that these are giant ionic, so they have ions. Oxide ions react with water to form hydroxide ions. We can do that as an equation. So the oxide ions, because it's giant ionic, reacting with water to give us 2 OH minus ions, hydroxide ions. And then the reason why sodium oxide is more alkaline is that sodium hydroxide that's formed is much more soluble than magnesium hydroxide, and so releases more hydroxides into the solution. Remember that key statement that magnesium hydroxide is sparingly soluble. Give an equation for the reaction of phosphorus 5 oxide. So we have to remember that although the formula, if we had phosphorus with a +5 oxidation state and oxide with 2 minus, we might think it's P2O5, but we have to remember it's P4O10. If that reacts with water, this is a non-metal oxide, a covalent oxide, so it's going to become an acid, and the acid is phosphoric acid. Then we need to balance that, 4 phosphoruses, so 4 of these. That's 12 hydrogens, so 6 waters. In the contact process, sulfur 4 oxide, so SO2, is converted to sulfur 6 oxide, SO3, using vanadium 5 oxide, V2O5, as a catalyst. Give 2 equations to show how vanadium 5 oxide acts as a catalyst in this process. So the first thing that vanadium 5 oxide does is it reacts with the sulfur dioxide, oxidizing it to sulfur trioxide or sulfur 6 oxide, and is itself reduced to vanadium 4 oxide. And then the vanadium 4 oxide is oxidized back by oxygen back to vanadium 5 oxide. It's the catalyst.